Hi, I'm Shresh Baumik, the team captain of Freeware Friends, the representatives of India in the OnStage category of RoboCupJunior. My team's performance surrounds the theme Farming in Space. We chose this because we wanted to portray a forward-looking message, particularly with how competitive and fast-moving the space exploration industry has become in the last few decades. In our display, you'll see how we've built a wide range of the potential robots that could be used on a fully autonomous farm, on a Martian colony, particularly on a version of Mars which is partially terraformed already. To start off, we began by designing how we wanted our robots and props to look, so that we could accurately shape our robots to the environment, and not the other way around, since this is how space missions would be carried out as well. By first sketching out our potential designs and creating props to simulate the terrain of Mars, we were able to build better robots to suit our purpose. Here you can see our initial sketches for the designs of our rover, humanoid, crane, and pollinator bots, all done by myself. Following this, our first props that we completed were the mountains that formed the backdrop of our performance to really give it that Martian vibe we were going for. We're using wooden slots and painted cardboard for our mountains to make sure that we have maximum stability without interfering with our performance. Once we'd built our robots to fit our designs, we had to test their strength and capabilities. Here you can see us testing whether our crane bot would actually be able to pick up the habitat which it is supposed to build. This is one of our 4 chosen technical features as well, interactions with props. Meanwhile, our second robot is a pollinator. We 3D printed a fan for this robot to use on its medium motor, and it is a must for any farm on a terraformed version of Mars, since there is very little wind on Mars when compared to Earth, meaning that plants would have a much harder time reproducing than usual. This robot represents two more of our technical features. The use of additive manufacturing, which is vital in space tech for rapidly creating tools in space, which might not have been carried aboard spacecrafts, and also precise locomotion of our robots to make sure that no energy is wasted while blowing pollen. Our final 2 major robots are a humanoid robot, as you can see here, and a rover. Our humanoid has 2 tools that it can use on the farm: a hoe to till the land before the seeds are planted, and a custom designed 3D printed water wheel, which it uses to water crops which are already growing. One of our major technical features is Bluetooth communication between robots, and as you can see, the humanoid sends a signal to the rover to begin planting seeds only once it has finished its own job of tilling the soil. The rover uses a custom designed 3D printed seed dispenser to perform this task, although the compartment for the seeds is not visible here due to this being filmed during the testing phase. For a more close-up look of how our humanoid robot's water wheel works, here it is. When the bot detects green underneath it using its color sensor, the water wheel spills regular amounts of water from the dispensing hole. For programming our robots, we used a combination of the EV3 Mindstorm's LabVIEW software and the Arduino IDE. Most of our code was written by Arush, although the Arduino C++ was written by Shresh. We chose to primarily use the Mindstorm software because our performance was developed in under 3 weeks, so our schedule was too tight to warrant using EV3's outdated Python module, which is a lot more buggy than the Visual IDE. To sum it up, here are our 4 technical features which you should grade us on. Firstly, locomotion, autonomous navigation, and obstacle avoidance. Secondly, our robots' prop interaction capabilities. Thirdly, multi-robot interaction and communication using Bluetooth. And lastly, the use of our additively manufactured farming tools and their suitability for the specific needs of a hostile Martian environment. We selected these 4 features based on what we thought would be the most vital capabilities of robots on Mars: navigation, interaction, communication, and adaptability. Thank you from the whole team for looking at our demonstration, and we hope you enjoyed the performance that I and the rest of Freeware Friends have created for you.